For centuries, people have looked at the night sky and thought we were alone in the world. With each technological advance, we get closer to finding answers. Now, in an announcement that could change our place in the universe forever, NASA has discovered the first extraterrestrial signals coming from Proxima B, the closest point to Earth. Proxima B is more than 4 light-years away from the habitable zone of its host star, Proxima Centauri. Very simple and structured, this symbol caused a wave of excitement and curiosity around the world. Could this be the moment when a man realizes that he is not alone in the world? The path to this great discovery began with the careful observation of NASA's powerful telescopes, which looked at distant stars and planets for signs of life. Proxima B has always been one of the main candidates in the search for extraterrestrial intelligence because of the Earth's shape and proximity to the solar system. The signal found was different and unlike anything astronomers had ever seen. It marked a turning point in human history. The consequences of that discovery are profound. First, it confirms the long-standing scientific hypothesis that other planets can exist under conditions similar to Earth's. Second, and perhaps interestingly, it raises the question of what kind of people will live there. Is it just a microcosm or an advanced human capable of communicating and traveling? This signal from Proxima B is not just random noise, a cosmic phenomenon. It is a structural repetition that shows a conscious origin. NASA scientists and international teams are now working to decipher this message and try to understand its message and intentions. The world's scientific community is immersed in theories and speculations about what this message could mean. Is it an invitation, a compliment, a warning, or something completely unexpected? The discovery sparked debate on social media, in cafes, and around the dinner table. People look up at the stars and wonder what creatures might be like that on a distant planet. How is their world similar or different from ours? How does your community feel about technology and culture? The world is as wide as it can be. In addition, this analysis opens up several ethical questions and concerns. If the sign is from intelligent people trying to communicate, how will people respond? What protocols should be created for interstellar mediation? And more importantly, how does such a discovery change our understanding of religion, life, and our identity as people? When the pressure is on, caution is also evident. Scientists at NASA and other space agencies are working hard to confirm these findings and ensure that the positive signal is not false or misleading. We are on the verge of discovering the greatest thing in human history, so we must take the next steps carefully. The world is waiting for further analysis. Seeing alien signals from Proxima B not only brings our science into a new era, but unites us with curiosity and hope. We may finally be close to answering one of the oldest and most profound questions. Are we alone in the world? In April 2019, a radio signal was detected from space, specifically from the region of Proxima Centauri, 4.37 light-years away. Although the distance seems great, it is the closest star to the Sun, 3 times the distance of the third brightest star in our sky. The symbol originates from a triple star system consisting of the binary pairs Alpha Centauri A and B and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, 2 companion stars, are very close to each other and are about the same size as the Sun. Alpha Centauri A is bright yellow and 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright and orange in color. Alpha Centauri A is smaller than our Sun and Alpha Centauri B is smaller, so our Sun falls right between them. But where is the sign between these 2 stars? The award has been named Breakthrough Listen Candidate 1, BLC-1. With a budget of nearly $100 million, this project has involved thousands of hours of observation with advanced telescopes around the world. This signal was detected by the Parkes Radio Telescope in New South Wales, Australia. This telescope observed the region of Proxima Centauri, the nearest star to our Sun. The signal was not found among the amount of data collected in thousands of hours, but the researchers found a needle in the haystack. To be considered a valid symbol, 2 distinct conditions must be met. First, it must be limited to a low frequency range, because these radio signals are not generated by natural machines in space. Second, the frequency should change based on the exoplanet's relative motion to Earth. About 4 million points were captured by a telescope in Australia by scientists. After extensive analysis and removal of unwanted signals, they found 5,000 unique signals, one of which could not be deciphered when scanning with modern radio transmitters. On the ground, this unique signal, with its narrow technical signature, only appears when the telescope is aimed at Proxima Centauri and is visible within 30 hours. After analysis, it was found to come from Proxima B, a planet discovered by astronomers in 2016 using the radial velocity method. This technique detects changes in a star's position due to the pull of rotating planets. The star shows a small circle, and scientists use very sensitive telescopes to track the star's light. As you move away, the light spectrum changes slightly to blue. These movements occur in daily patterns throughout the day, month, or year, and the lunar cycle is attributed to the gravitational pull of a rotating planet. A closer look shows that Proxima B is very similar to Earth, 1.1 times the radius of Earth, and 1.3 times the mass of Earth. However, there are significant differences. The first is the position of the two planets in their respective solar systems. Proxima B is closer to its host star by just 5 cents, while Mercury is 39 cents from the Sun. This proximity makes Proxima B the hottest planet, but because Proxima Centauri is a faint red dwarf, it receives 60% of the energy that Earth receives from the Sun and puts it inside where to live for a living. There are many unknown planets scattered throughout our universe. So far, we have discovered 4,935 exoplanets and 65 new ones, bringing the total to 5,000. This new group of 65 exoplanets was added to NASA's Exoplanet Archive on March 21st of this year. A milestone in planetary exploration. The James Webb Space Telescope, JWST, is the most advanced telescope ever built, 100 times more powerful than its predecessor. With his help, we can unlock the secrets of the universe. In the past, we have discovered a wide range of planets, from small rocky worlds to gas planets larger than Jupiter, to the hottest and most habitable planets. Among these observations, some planets stand out. Kepler, 1649c, is one of the planets with similar characteristics to Earth. In fact, it is the most beautiful planet we have ever seen that can support life. We've discovered 55 Earth-like planets so far, but we haven't been able to study them all. With our rapidly advancing technology, especially thanks to the James Webb Space Telescope, who knows what else we can achieve in the future? Wouldn't it be wonderful to find a planet that could support life? One of the main goals of the James Webb Space Telescope in its first year of scientific operation is to find and study exoplanets outside our solar system, focusing on the nature of structure and form in water and biological substances. The extensive internet research into star and planet formation allows us to link studies of mature exoplanets to the conditions of their birth, and also to link our own solar system to their origins. Webb's infrared capabilities are ideal for revealing how stars and planets form for 3 peculiar reasons. Infrared light penetrates dust well, detects the thermal signatures of young stars and planets, and indicates the presence of key chemical components such as water and organic compounds. Mid-infrared light can pass through clouds that are 20 times denser than visible light, which is especially important when observing newborn stars hidden within their natal clouds. These infrared capabilities are crucial because they allow us to observe and capture the early stages of star formation when gas and dust are still contracting to give birth to young stars. But there is much more to the natal clouds of stars than that. Both young stars and giant planets begin as huge, swollen structures that gradually contract over time. As newborn stars burn up over the years, the giant planets cool, but both are brighter in the infrared spectrum than in visible wavelengths. The Webb telescope is expected to be useful for finding new stars and planets and helping to understand the physics of their formation.